Now, for example, 1C, we need to point out something super important, which is a warning, and I'll articulate this. But basically, the critical points, which remember are our stationary and singular points, they need to belong in the domain of the function. This means it's a point that's on the actual graph. So if we have a singular point, which is where the denominator of the derivative is 0, at some value we'll say a as a placeholder. So the derivative of a does not exist. That's what makes it singular. But to be in the domain, the function at the point A does need to exist, and that's not going to happen here. So let's take a look. As you know, whenever we want to find stationary or singular points, first thing we do is take the derivative, and looking at our function f of x equals 1 over x, it's not ready to take a derivative because the x is in the denominator. So first, we need to rewrite the question so that we can take a derivative. Taking f of x equals 1 over x, our x in the denominator can be rewritten as x to the negative 1 power, and now we're ready to take a derivative. Negative 1 times x to the negative 2, or more specifically, negative 1 over x squared. So to find our stationary point, we take negative 1 over x squared, and we really look at when does the numerator equal 0? Well, since there's no variable, this means there is also no value that we can create to change negative 1 into 0. So we will never have 0 in the numerator of this function. So we have no stationary point. That's not specific to this domain example, just happened to make it easier. Now for the singular, again, we take our derivative and we care about when the denominator equals 0. Again, we can solve this piece because it does have a variable. So I have x squared equals 0. Because I have a squared power, you instinctively know to take the square root. Remember, it's the reciprocal of the exponent. Also, I should really have plus or minus the square root on the right side because it's not squared, but since it's 0, it's a moot point, and I will elaborate that in the next line. It should have been plus or minus 0, but there's no such thing as positive or negative 0. It's neutral, so x was just 0. Because I need to answer as a coordinate, this is where the issue of the domain comes into play. I found a critical value. I do have a critical value at x equals 0. But when I go to list it as a critical value, when I go to find the function of 1 over x, and I plug in my 0 value, what happens is, oh no, this is undefined, and we have to throw this answer out. So actually it's not a critical value. I found a candidate, but it technically was not on the graph. So since it's not in the domain, it's not a critical value. And for this particular problem, there were no stationary or singular points.